Very good morning. Today we'll be talking about two-way between the subject analysis of variance ANOVA. Previously we have talked about one-way ANOVA. In case of one-way ANOVA, we had one independent variable which was in category form or nominal form, and the number of categories was more than two, and the dependent variable was in scale form. Today, on talking about two-way between the subject analysis of variance, or commonly you can say we'll be calling it two-way ANOVA, we'll be having two independent variables and one dependent variable. The independent variable will be in categorical form, having two or more than two categories each, and we'll have the dependent variable in scale form. So let's look at the example for two-way ANOVA and see that okay how we are conducting two-way ANOVA. The example is a researcher wanted to investigate the effect of physical therapy and relaxation exercise on back pain. 24 people suffering from acute pain were recruited from a local orthopedic clinic for the study. Two different types of physical therapy and relaxation exercises were investigated. For physical therapy, half, that is 12, of the participants used stretching exercises, another half, that is the remaining 12, used strengthening exercises. For relaxation exercises, half, that is 12 of the participants, used muscle relaxation, that is tensing and relaxing muscles, starting with the head and moving to the toes, and the half, 12, used guided imaginary, a studied structured visual technique intended to aid in relaxation. So this is the example, and here if you look at the example, we have got two independent variable, that is physical therapy and relaxation. So how they are impacting or affecting, you can say, back pain is to be taken up. Physical therapy and relaxation are in categorical or nominal form, and back pain is in scale form. So we have the sample size of 24 people who are suffering from acute back pain, and they have been, you can say, given physical therapy and relaxation exercise. So two different types of physical therapies are being given, and we have, you can say, half of the participant, that is 12, getting stretching exercises, and the remaining half getting strengthening exercises. So physical therapy is of two types, strengthening and stretching, and relaxation exercise, half of the people are getting muscle relaxation, and the remaining half are you getting guided imaginary, you can say, therapy. So if you look at, you can say, the example, you will find that we have got um, both independent variables in category form, that is, you can say, having two categories each. So physical therapy has got two categories. One is stretching exercise, and the other is strengthening exercise. Whereas relaxation exercise has got two ways of relaxation. One is muscle relaxation, and the other is guided imaginary technique. So looking at this example, let's look at the hypothesis we want to create. If you look at two-way ANOVA, here we'll be having three hypotheses coming up. The first hypothesis is related to the first variable. In our case, the first independent variable is physical therapy. So we are trying to see whether the two categories in physical therapy are having either uh, no different effect or maybe significant effect on the pain level. So we have got strengthening exercises, and we have got um, stretching exercises. So we have got two types of physical therapies, and we are trying to see that test of physical therapy, that is stretching versus strengthening. So null hypothesis is basically trying to say that there is no significant difference as far as pain level is concerned and the physical therapy the patient has gone for, either strengthening or stretching. So even if you look at, you can say the things over here, you will find hypothesis null 1, mean of stretching is equal to mean of strengthening. So that is the null hypothesis. Altered hypothesis will say that there is a significant difference as far as the pain level of patients is concerned and the physical therapy they have gone for, that is stretching versus strengthening. So we have, you can say, the alternate hypothesis HA1, where mu stretching is not equal to mu strengthening. So that is hypothesis 1. Similarly, we are going to phrase, you can say, hypothesis 2 for the second variable we have got, the independent variable, and that is talking about the relaxation exercise. Now here we know, and if you look at the example again, you will find we have got two types of relaxation exercise. One is muscle relaxation and the second is guided imaginary. So here we are just trying to see that is the relaxation exercise, that is muscle relaxation or guided imaginary, are they having no significant differences as far as pain level is concerned, or are they having significant differences as far as pain level of the patient is concerned? So here you can say we have the null hypothesis, that is H and 2, where mean of muscle relaxation is equal to mean of guided imaginary. This means that there is no significant difference as far as the relaxation exercise, either muscle relaxation or guided imaginary is used, and the back pain of the patient. Whereas if you look at the alternate hypothesis, it is HA2, which says mean muscle relaxation is not equal to mean guided imaginary. Now, if you look at this hypothesis, this means that there is a significant difference as far as the relaxation exercise, either muscle relaxation or guided imaginary is used, and the pain level of the patient. So that is hypothesis 1 and hypothesis 2 we have talked, which were related to variable 1, independent variable 1 and independent variable 2. Hypothesis 3 is basically an interaction of variable 1 or independent variable 1 and independent variable 2. So it is also known as test of interaction effect. So that is, you can say, test of interaction effect of the two variables. And here we have got the two variables, the independent variables, I mean, as physical therapy and relaxation exercises. So if you look at the null hypothesis, it is stating that there is no interaction. There is not an interaction between the two variables, or there is no interaction between the two variables. So there is not physical therapy and you can say relaxation exercise interaction. So that is given as H and 3. Whereas the alternate hypothesis says that the two population means are not equal. So this means that there is physical therapy and you can say relaxation exercise interaction taking place. So these are the hypotheses which we have framed. And now coming to research question. Here again, we'll have the three research questions coming up related to, you can say, the three things we have got. The first two is related to independent variable 1 and independent variable 2, and third is the interaction between the two variables. So the research question 1 is talking about physical therapy, and the question is, does the reported pain level for those who used stretching exercises versus those who used strengthening exercises? So we're just talking about, you can say, difference in pain level. You can say for people who are using stretching or strengthening exercises. Similarly, for relaxation exercises, again, we are talking of, does the reported pain level differ for those who used muscle relaxation versus those who used guided imaginary? So again, we are just trying to question that, okay, fine, whether the significant differences are there or not for both independent variable 1 and independent variable 2. Now coming to the interaction part, which becomes our third research question, we are talking about the interaction of physical therapy, that is the first independent variable, with the second independent variable, that is relaxation exercise. So the question is, does the reported pain level for therapy depend on whether muscle relaxation or guided imaginary was used? So that is what you can say our research questions are. Remember, you can say when we are doing two-way ANOVA, we have got three hypotheses being framed, two for the two independent variables we have got, and the third one, the interaction between the two you can say independent variable, if it is there or not. Similarly, we are having three research questions, and the research question 1 and 2 are on um, independent variable 1 and 2 respectively, whereas the third one is again talking about the interaction between the two independent variables. So that being the case here, we are now coming to the data of the example which we are talking about. We are talking about the back pain level of people. We have got 24 people at present, and they are going through, you can say, two types of you can say um, um, therapies and exercises. One is physical therapy, and second is relaxation exercises. Now, physical therapy, few of them or half of them are going for they are going for basically stretching exercises, and the remaining half are going for strengthening exercises. Whereas for relaxation exercises, half of them are going for muscle relaxation, whereas the remaining half are going for guided imaginary. So that's the data here. Now this data is being, you can say, worked up this way, that we have got 24 participants. The details are in the next page, which I'll be showing you in a while. And we are giving, you can say, stretching exercises as one. That is, you can say we are creating a variable called physical therapy. There we'll have stretching exercises as one, you can say, will be coded as one, whereas you can say strengthening exercises will be coded as two. And for relaxation exercise, you can say those who have, you can say, received muscle relaxation, they'll be given number one, and those who received guided imaginary are being assigned two. So that is how you can say data is being prepared. The data is given to us, and I'm moving you to the next slide, next page. So this is what the data is. So we'll be working on data. So you just wait for a while. I make you can say take you to the SPSS file for that. So here we are, we have got this is the data view, and I've just, you can say, pasted the data, you can say, here. So we have got 24 number of people here who are patients and having back pain, and they have gone for physical therapy and muscle relaxation. So we know that. So let's move to the variable view, where we'll be naming the variables. The first one is, you can say, physical therapy. I'm just writing it in short form. So PHYSICL, physical therapy is one. And here we are going for um, the values. So we have got one as stretching. So stretching, and two as strengthening. So this is, you can say, the two value labels we've got. I'm adding it here, and moving to the measure, we all know it is nominal. So moving to the next variable, which is a relaxation exercise, and I'm just writing the label here. Again, we need to, you can say, create value, because we have got two types of relaxation exercise. Number one is muscle relaxation, and second is guided imaginary. So this is, you can say, the two variables, sorry, two categories of the second independent variable. And now I'm putting up the measure. Again, we know the measure is nominal. Coming to third, it is talking about the pain level. So I'm just writing the word pain over here and writing, you can say, back pain level. So that is my, you can say, level here. Values are not mentioned because the pain is at a specific level, and we know higher the level of the pain, higher the value there. And the measure actually happens to be the scale one. It is actually interval scale. So that's here. If you look at the data view, this is how the data view is coming. So we have physical therapy, we have relaxation exercise and pain, and we have got the values for all 24 respondents. So that's there. Moving to the analysis part now. So I'm talking about doing or conducting, you can say, two-way ANOVA. For that, we go to analyze. We go to general linear model, and we are moving to something called univariate variable. I click on that. Once I've clicked, this is the univariate box I've got. So I'm putting physical therapy and relaxation exercise as, which are the two independent variables, as fixed factors. Back level, which is a dependent variable, as dependent variable here. I'm moving to, you can say, something here. The first one I'm doing is I'm clicking on this EM means, and then maybe I'm looking at, you can say, all. I'm just, you can say, selecting physical therapy, relaxation exercise, and interaction between physical therapy and relaxation exercise as estimated marginal means I will be looking forward for. So this is I'll be getting, not for overall. I'm just doing it for physical therapy, relaxation exercise, which are two independent variable, the mean of them, and then maybe you can say the interaction that takes place between physical therapy and relaxation exercise. So I'll click on continue. Then I am talking about the second thing, options. I click on options. I will click on descriptives just to have descriptive stats, just to have estimate of effect sizes and homogeneity test. So three things I'm doing here. I'll click on continue, and then I'll move to plots, and I'm plotting, you can say, horizontal axis. I'll be plotting, you can say, physical therapy. Relaxation exercise, I'll be plotting in separate lines. Remember one thing, since you can say both physical therapy and relaxation exercise have got two categories, I'll be plotting them as PT in horizontal exercise and relaxation exercise in separate lines. If any one of these was having more categories, then that would have been, you can say, placed in horizontal axis. I repeat, had the category for PT or RE been greater to other, I would have plotted that in horizontal axis. And then I'll simply, you can say, uh, do add, and then I'll say continue. So that's there. And now I'll be clicking on OK. The moment I click on OK, I'll be getting the responses in my output file. So I'm sharing the output file with you. So this is here I am having the output file before you. So this output file is now available before you. You are seeing the output file. And this is how you can see the univariate analysis of variance is taking place. We have got two variables here. We have got, you can say, physical therapy and relaxation exercise, which are, you can say, the two independent variables. And we are just saying that, okay, fine. Stretching is being given, you can say, a label 1. Strengthening has been given label 2. And we have got 12 each respondents in the two categories. Similarly, for relaxation exercise, muscle relaxation has been given value 1, guided imaginary has been given value 2, and again we have got 12 people each in both the categories. Now coming to the descriptive stats, which we are having here. So we are having, you can say, the descriptive variables coming up. So we have got, you can say, physical therapy. Now physical therapy stretching is, you can say, looking at, you can say, relaxation exercise, the stretching, and you can say people who went for stretching and went for muscle relaxation. We had 6 of them, and this is their mean, that is 24 something, and standard deviation 4.2 something. Those people who went for, you can say, guided imaginary and as a relaxation exercise, and simultaneously they had gone for, you can say, stretching, they had the mean pain level of 40 something and standard deviation of 7.3. Again, we have got 6 people here. Overall, if I want to see, you can say, what is the you can say mean pain level of people who went for stretching. It's about 32 something, 32.5, and standard deviation is 10.4 something. We had 12 people in all. So that is about stretching. Similarly, if you look at the physical therapy being strengthening, their muscle relaxation and guided imaginary, we had 6 people each. The mean was 45 something and 48 something for each of them. And then we had the standard deviation 5.8 and 4.2 again for each one of them. So this is known to us. And for strengthening, you can say the mean, you can say pain level is 47 something with the standard deviation of 5 something. And we had 12 people who went for strengthening. So this way we are able to understand how, you can say, things are spread when we are talking about the two independent variables, and then from that point of view we are looking at the dependent variable. So we are able to see, okay, fine, where the four of the things stand up here. For, you can say, two for, you can say, physical therapy, two for relaxation exercise, and we know the relationships that is coming up. Done. So we are having that relationship coming up. We are able to understand the values being shared here. What I basically say is that for strengthening, you can say the things are not much different. Whether it is, you can, muscle relaxation or guided imaginary, it's about 45 and 48 each, quite near to each other. Differences are there, but it doesn't appear to be too big. Whereas for stretching, if you look at muscle relaxation and guided imaginary, the differences supposed to be huge. But are they contributing significantly or not? That we will be, you can say, looking up a bit later. So that was just a description, just to understand the problem. Now coming to, you can say, Levin's test of equality of error variances. That is something we are trying to always do when we were doing t-test also, that the respondents which we have got, or the sample we have got, is it coming from the same population or is it coming from different population? So if it is coming from the same population, homogeneity of variances will be there, or test of equality will be there. Here, if you look at, you can say based on mean, the Levin statistic is 1.2 something, and the significance is 0.322. Now, significance of 3.322 basically means that um, the Levin's test of equality is there, and you can say the two, you can say, groups of, you can say, we are having, you can say, are coming from the same population. So significance of 0.332 proves equality of variances. Had it been, you can say, less than 0.5 or even 0.5, we would have said that equality of variances is not proved here. So that is the case. So this is Levin's test of equality of variances. Now talking about, you can say, something more we are getting. Look at this. If you look at, you can say, the ANOVA or two-way ANOVA which has been done. So let's look at physical therapy. And the sum of squares for physical therapy is 12 something, 12, 1276 something. Degree of freedom is 1 because we have got two categories. So 2 minus 1 is 1. Mean square value you are getting, F value you are getting. So F value happens to be, you can say, 41 point something. So 41.174. Significance is quite high. So significance is coming to 0.000. Whereas if you look at, you can say, you're looking at relaxation exercise. Again, you can say some of squares, leave that part right now. Just look at, you can say, the F value. F value is 17 something. Again, a very high significance is coming up. And even if you look at, you can say, physical therapy and relaxation exercise, and look at, you can say, the F value, it happens to be, you can say, 9.714, which is again, you can say, quite significant, 0.05. So this means, you can say, we are having all the three, you can say, hypotheses, which we have seen, you can say, originally are being, you can say, accepted for, you can say, for alternate hypothesis. All the three, you can say, test we sorry hypothesis we have framed, we are accepting that there is a significant difference as far as physical therapy being conducted through stretching or physical therapy being conducted through strengthening are concerned, and the pain level you can say of the of the patients. And similarly for relaxation exercise, whether you are going for muscle relaxation or you are going for guided imaginary, in both the cases the differences are significant as far as back pain level of the patient is concerned, and therefore we are accepting the alternate hypothesis. Similarly, you can see the interaction that is taking place between physical therapy and relaxation exercise, and its impact on, you can say, pain level is supposed to be, you can say, significant. And then we are also accepting the alternate hypothesis for hypothesis 3. So that being the case for, you can say, accepting the hypothesis, just you can say here we are looking at, you can say, the mean value for stretching is 32, for relaxation, for strengthening it is 47 something. So that's for physical therapy. For relaxation exercise, you can say muscle relaxation, the mean 35 something, guided imaginary it is 44 something. So that we are seeing. And then maybe you can say physical therapy, relaxation exercise, these values of stretching and you can say strengthening are coming, and maybe you can say this possibly we are seeing that okay fine if significant differences prevail or not. And then maybe you can say this is just a plotting I've done for you to understand that if you look at, you can say the two things, maybe you can say if I'm looking at, you can say stretching and strengthening, maybe you can say this is stretching and this is strengthening. So this is, maybe you can say this is what we are seeing, that how they are moving. And when maybe you can say between you can say stretching and strengthening, you can say how you can say how the muscle relaxation is moving. So you see that muscle relaxation has got a much larger range as far as you can say, if you look at, you can say how they spread between stretching and strengthening. And similarly, you can say guided imaginary has got a lower range. If you look at the two, you can say strengthening, and look at, you can say how the guided imaginary is there. So we have just gone through the test, we have seen the data, and we have done the things here. Now we are moving back to our previous screen where I'll be, you can say, uh, talking to you about the final answers. So finally coming to the conclusion and answer of the test we have conducted, we have seen how and when this two-way ANOVA is conducted. Just to sum up the things, we know that when we have independent variable, rather two independent variables having categories two or more, and then a dependent variable where which is in scale form, a condition of two-way ANOVA is there. We also know that we have got three hypotheses being framed for two-way ANOVA. Hypothesis 1 is talking about independent variable 1. Hypothesis 2 is talking about independent variable 2. And hypothesis 3 is talking about interaction between the two independent variables. Research questions similarly will be 3 for for independent variable 1, independent variable 2, and the interaction between the two independent variables. So coming up with, you can say, the final points of this question here. So one thing we should always know that there's something called effect size, and we have been talking about effect size previously. In case of um, two-way ANOVA, effect size, which is determined by eta square, is given by this formula. So we'll be using this formula to find out the effect size. So you can easily look at the effect size which we are having. So effect size is given by SS effect divided by SS effect plus SS error. So just letting you know how we are going to, you can say, go for effect size. I'm taking you to the output file for a while. And if you look here, you will know what effect size is. If I want to know the effect size of physical therapy, for physical therapy, the effect size is this value, 1276.042. divided by the sum up of this value 1276.042 plus 619.833. So when I do the calculation, I'll get the value. Similarly, I want to, you can say, find the effect size for RE, that is reduction exercise. So in numerator, I'll have the value 551.042. In denominator, I'll have the value 551.042 divided by 619.833, which is error value. Similarly, you can say, if I have to find, you can say, the effect size for PT interacting with RE, that is physical therapy and relaxation exercise interaction. So the numerator will be 301.042, denominator being 301.042 plus 619.833. So this is the formula we are going to use to find out the effect sizes. We'll be getting the three different effect sizes for our answer in two-way ANOVA. The formula is known to you. You can look at the value and you can get the effect size. So we'll be getting the effect size this way. Done. Now, how are we going to write the result? How are we going to write the result? A 2 cross 2 between subject ANOVA was conducted with back pain as dependent variable and physical therapy, stretching, strengthening, and relaxation exercise, muscle relaxation, guided imaginary as independent variables. The result indicated that there was a significant main effect for physical therapy, F1, that is the degree of freedom 1, and degree of freedom 2 is 20. So degree of freedom 1 is because for physical therapy, we have got how many categories? 2. So 2 minus 1 is 1, and degree of freedom is 20 for, you can say, the second you can say degree of freedom. Why? Because n is equal to 24, and we have got four categories: two of physical therapy and two of relaxation exercise. So we have got four categories in totality of the two independent variables. So it is 24 minus 4 is 20. So this way we are getting F within brackets 1 comma 20 is equal to, you can look at the table again, output table, and the value is 41.17. P is less than 0.05, and partial eta square happens to be 0.67. We understood how to calculate eta square a few moments back. With those using stretching exercises, mean is equal to 32.5, standard deviation is 10.41, reporting significantly less pain than those using strengthening exercise with mean is equal to 47.08 and standard deviation of 5.04. There was also a significant mean effect for relaxation exercise F1 and 20. And again, one is because we have got only two types of, you can say, relaxation exercises, that is um, muscle relaxation and guided imaginary. So 2 minus 1 is 1. And then degree freedom 2 is 24 minus 4 categories we have got. So it is 1 and 20 is equal to 17.78, which is quite high. And then we have P is less than equal to, sorry, less than 0.05 with partial eta square. You can calculate it there is equal to 0.47. With those using muscle relaxation, mean is 35 and standard deviation is 12.31, reporting significantly less pain than those using guided imaginary. Mean is equal to 44.58 and standard deviation is equal to 6.95. There is also a significant physical therapy by relaxation exercise interaction. FS 120 is equal to 9.71, P is less than 0.05, partial eta square is 0.33. For strengthening, there is a little difference in pain between the muscle relaxation and guided imaginary conditions. While for stretching, the difference in pain between the muscle relaxation and guided imaginary conditions was large, with muscle relaxation resulting in substantially lower pain. So this is how you can say the result is put up. I will be sharing the SPSS file for this example plus the notes which are detailing everything. And I would request you to just go through this particular um, you can say video again and again, just to understand how two-way ANOVA is conducted. more of a continued second, you can say, video on the exercise one question. I'll be giving you again as video two for this two-way ANOVA exercise. So please go through. And also for the question, which was an assignment question, few days later you will be having um, the solution video coming for the same. So you have got three videos to understand, you can say, this concept of two-way ANOVA. Hope you will enjoy this video and your learning of two-way ANOVA. Thank you.